Alright, so on these Johnson stats, the first thing you want to really check on them is whether this exhaust port is covered in dust. If you get a lot of dust in here, it'll keep this from sealing properly. If you get a leak here at all, it's usually in most cases going to result in loss of pressure and heating. So if you got a space that's overheating, start by checking there. The easiest thing to do to clean it is take a pipe cleaner or something, just drag it behind there lightly and just clean the dust off of it. This is a direct acting thermostat. You can see it's labeled on this. This is your bimetal strip. This is essentially how the thermostat works. So as the temperature in the space increases, the pressure the stat is sending to your valves or dampers increases. Since this thermostat is set at 55 and we're seeing about 75, we can either assume that there's a leak or that this thermostat is out of calibration. To check calibration on these, I find it's usually best to start off at the lowest setting, so that's calling for pressure at the stat. That way you can listen for any leaks first. As you start to turn this dial, what you want to listen for is when it relieves that pressure. If you use your infrared and shoot next to the stat. So it's 80 degrees and it thinks it's 10 degrees cooler. The way to calibrate that is this set screw here. You turn it clockwise, you increase the temperature that it thinks it is, you turn it counterclockwise, you decrease. So since it's actually 80 degrees in here, if we set this to 80, you take a little flathead screwdriver and you can turn this until it pressurizes again. So there you hear it build pressure. And then just to check your calibration, you got to kind of step away for a little bit because that metal strip's very sensitive. Your body heat will make it flex. So after you stepped away for a couple minutes, you can come back, turn this dial, and there you started venting pressure at about 78. So it's closer. I say if you can get these within a degree or two, that's good enough. I wanted to stop and clarify something about thermostat calibration before we moved on here. When your room temperature and set point dial are the same values, let's say 72 degrees, you're going to be sending an 8 psi control signal to a control device. There's a sensitivity slider screw that should never be adjusted on these, and that's highlighted here. If this gets adjusted, you can completely screw up how your thermostat works. Per the factory settings, let's say you're calibrated at 72 degrees. When you turn the dial down for cooling, you're going to have to go down about 5 degrees, down from 72 to about 68 before you're in full cooling at 20 psi. For heating, you're going to have to go about 3 degrees above to get into full heating, which would be about 75 degrees. So we can hear a leak at the thermostat. Usually an easy way to tell whether it's at the stat itself or if it's up at a valve or damper or somewhere in the wall. If you take the cover off, you can check the seal on the back. If you hear the leak right here, then the thermostat seals are bad and they'll need to be replaced. If it were a quieter environment, you could check to see if this has a metallic sound to it, like it's ringing. That indicates air is just blowing through the thermostat and not a leak at the stat itself. They've got these color coded. The red is your supply air, 20 pounds, so that'll always have pressure on it. As this vents air, you'll stop sending air here, and you'll start discharging more heat. So that's your output line. Typically in the wall, there's a mounting bracket where you've got copper lines that come down and meet. They go to a mounting bracket that has two little ports on the front that these plug onto. Those ports can leak over time. Thanks for watching. Included here are the operating manual links for the most common thermostats on campus. I hope we've been of help.